Hello all, welcome to the section in real analysis 2. In this section, we are dealing with the Cauchy sequence and properties of Cauchy sequence in non-linear spaces. Okay, we all know the definition of Cauchy sequence in non-linear space. A sequence is Cauchy means when norm of fn minus fm is less than epsilon for every n and m greater than or equal to some fixed integer n. Okay, that means after the stage, any two elements in that sequence have near to each other. Okay, so we will prove a proposition. This proposition says that suppose we have a normed linear space X with a norm, some norm, then if you consider any Cauchy sequence, if you consider any convergent sequence, suppose we have a sequence Fn, suppose it is convergent, then we are going to prove that it is Cauchy. Convergent implies Cauchy. Okay, every convergent sequence in X is a Cauchy sequence. Okay. Moreover, if you consider a Cauchy sequence in a normed space X, if Fn is a Cauchy sequence, Fn is Cauchy, okay, then it is converges if it has a convergent subsequence. That means if Fn is Cauchy and its subsequence, suppose it has a subsequence Fnk and it is convergent, then this sequence will be convergent. So these are the two results prescribed in this proposition. So if Fn is a convergent sequence, then it is Cauchy. Okay, convergent implies Cauchy. That is the first statement. Second one, if Fn is Cauchy and if it has a convergent subsequence some Fnk, then Fn will be convergent. Okay, every convergent sequence is Cauchy. Cauchy sequence will converges only when it has a convergent subsequence. Okay. So how will you prove this proposition? So to prove this, I take let X together with some norm is a normed space, normed linear space. Okay. And let Fn be a convergent sequence. Fn be a convergent sequence in X. We need to prove that it is Cauchy. Since Fn is convergent, by definition, for every epsilon greater than 0, there is an integer n in n such that I can write limit n tends to infinity norm of Fn minus f is equal to 0. Right? Limit n tends to infinity norm of Fn minus f is equal to 0. Okay. To prove it is Cauchy, for the same epsilon greater than 0, I consider Fn minus Fm. Okay. This can be written Fn, I add and subtract f because f exists. Okay. Fn minus Fm. And by triangle inequality, since it is a normed space, it satisfies the triangle inequality. So this will be less than or equal to, I can write some Fn minus f plus f minus Fm. Okay. And what is this? We know this goes to 0 since Fn converges to f and for some integer n. Right? So this will be, I can write for every n and m greater than or equal to that integer n. Okay, the same integer n, this will be goes to 0. This goes to 0 means limit goes to 0 means Fn minus Fm actually is less than epsilon. Right? So I get this will be less than some, I take epsilon by 2, then this will be less than epsilon by 2. This is also less than epsilon by 2, so you get epsilon. So norm of Fn minus Fm will be less than epsilon for every n and m greater than or equal to that is same integer n. Okay. So which implies Fn is Cauchy. So every convergent sequence will be Cauchy in normed linear space. Now for the second statement, when a Cauchy sequence converges if it has a convergent subsequence. So for the second statement, I take let Fn be a Cauchy sequence in capital X and Fnk be a subsequence of Fn such that Fnk converges to some f in X. Okay. We need to prove that our claim is this Fn, sequence Fn converges in X. Okay. So to prove that convergence, we are using the convergence Fnk converges to F. And Fn is Cauchy. Since Fn is Cauchy, by definition, for every epsilon greater than 0, there is an integer n in n such that for every n and m greater than or equal to that integer, we have norm of Fn minus Fm is less than epsilon. Suppose equation number 1. I take some epsilon by 2, okay? Now, since the subsequence Fnk converges to F, for the same epsilon greater than 0, for the same epsilon greater than 0, comma, I will have there exists an integer, some nk corresponding to this nk, okay? Nk in n such that, I will have norm of Fnk minus F will be less than epsilon by 2 for every nk greater than or equal to, for every, I take some that is nk prime, nk greater than or equal to nk prime. Now choose n1 equal to maximum of this nk prime and this n, then these two equation will be hold for this n1. Okay, now consider, I need to prove that it is convergent, right? Consider norm of Fn minus F. What is this? This can be written norm of Fn minus Fnk. I will add and subtract the term Fnk plus Fnk minus F. So this will be less than or equal to, by triangle inequality, this will be norm of Fn minus Fnk plus norm of F minus Fnk. Okay. Since Fnk converges to Fn, this will be less than epsilon by 2 and this will be less than epsilon by 2. So we get which is less than epsilon. So which implies our sequence Fn is converges to F, or in particular every Cauchy sequence converges when it has a convergent subsequence. So Fn converges if it has a convergent subsequence. Okay. Now we will discuss the concept of rapidly Cauchy sequence in non-linear space. So a Cauchy sequence means if Fn is Cauchy, then after a particular stage, distance between or difference between any two elements in that sequence will be tends to 0 or less than epsilon. Yeah. A sequence is said to be rapidly Cauchy means, if suppose we have a sequence Fn which is said to be rapidly Cauchy, means corresponding to this sequence Fn, we need to find out a convergent series of positive numbers. K equal to 1 to infinity, some epsilon k, some ek, okay, some ak, okay. And this must be convergent. Corresponding to this series, we need to find out a convergent series of positive real numbers such that when you find out the distance between fk plus 1 and fk, that must be less than or equal to its square of the elements for every k. Okay, this is the definition of rapidly Cauchy sequence. For example, if you consider the sequence 1 by n square, okay, in real line with the modulus, which is a normed linear space. So I consider X as this space and you take Fn is equal to 1 by n square, okay. You know this is a sequence, okay. Then I consider the series sigma 1 by n square, or I take k square, k equal to 1 to infinity. You know this is a p series with p equal to 2. Clearly it is a convergent series, okay. Convergent series of positive numbers. This is a square, therefore it is always positive. positive numbers. Okay. Then we want for every k we have to get modulus of norm of fk plus 1 minus fk is less than or equal to epsilon k square. Okay, so you consider what is norm of fk plus 1 minus fk. Since it is a real numbers, our normed space is real, this fk plus 1 and fk are real numbers. So in order to use the norm, I consider modulus fk plus 1 minus fk. And what is this fk plus 1 minus fk? Fk plus 1 is fn is 1 by n square. So fk plus 1 is 1 by k plus 1 square minus 1 by k square. So this can be written some k square minus k square plus 2k plus 1 divided by k plus 1 square into k square. Okay, modulus. So that is equal to actually minus of 2k plus 1 divided by k square into k plus 1 square. Okay. Since this is will be always less than or equal to 1 by k raised to 4. Okay. This will be always less than or equal to 1 by k raised to 4. And 1 by k raised to 4 can be written 1 by k square whole square. Right. So what is this 1 by k square? 1 by k square is an element in the series sigma k equal to 1 to infinity 1 by k square. So this is some epsilon k, then we get 1 epsilon k square, or this can be written 1 by k square the whole square. So this is, what is this? This is epsilon k. Okay. So I can say that 1 by n square is a rapidly Cauchy sequence. So fn equal to 1 by n square is a rapidly Cauchy sequence in realign with the modulus as norm. So this is about rapidly Cauchy sequence. Now we are looking for, is there any relation between rapidly Cauchy sequence and Cauchy sequence? Okay, so this proposition asserts that every rapidly Cauchy sequence in X is a Cauchy sequence. In a normed linear space, every rapidly Cauchy sequence is Cauchy. And for the reverse one, we have every Cauchy sequence has a rapidly Cauchy subsequence. Every Cauchy sequence has rapidly Cauchy subsequence. Okay. So every rapidly Cauchy always implies Cauchy. But Cauchy is not implies rapidly Cauchy. Cauchy sequence means has a convergent, has a rapidly Cauchy subsequence. Every Cauchy sequence has rapidly Cauchy subsequence. So this is the relation between Cauchy and rapidly Cauchy. So how can you prove this two relationship? So first one, we need to prove a rapidly Cauchy sequence is a Cauchy sequence. So let Fn be a rapidly Cauchy sequence in a normed linear space X with some norm. Okay. Therefore, corresponding to this, by definition, then there exists a convergent series of positive numbers sigma k equal to 1 to infinity some ek or epsilon k, such that we will have norm of fk plus 1 minus fk will be less than or equal to ek square for every k. Okay. Now we consider for any k, you consider what will be fn plus k minus fn. fn plus k minus fn. And this will be nothing but sigma j equal to n plus k minus 1 some fj plus 1 minus fj for every n and k, right? What is fk plus 1 minus fk? Fk plus 1 minus fk is epsilon k square. Then fk plus 2 minus fk plus 1, fk plus 2 minus fk will be some epsilon k square. So summing up all, we get fn plus k minus fn will be the difference between after the stage n and or between the stages n to n plus k minus 1. Ready? So what will be their norm? Fn plus k minus fn will be equal to norm of this sigma j equal to some n to n plus k minus 1 fj plus 1 minus fj, and this will be less than or equal to, by using the triangle inequality there are sum of two or more terms, so that will be less than or equal to sigma j equal to n to n plus k minus 1 norm of fj plus 1 minus fj, and we have this is less than or equal to, so I can write this is less than or equal to when j equal to n to infinity, and this will be less than or equal to the whole sum. So I take j equal to n to not n plus k minus 1. I consider the after the nth stage I consider the all the sum. That means the tail of that series. Okay. So that, and what is this fj plus 1 minus epsilon fj is will be less than or equal to some epsilon j square. Okay, epsilon j square. And what is this epsilon j square? We have assumed that sigma k equal to 1 to infinity epsilon k is a convergent series. Okay, then what will be that? When a series is convergent, that square will be also convergent. Therefore, epsilon j square will be convergent. When a series is convergent, what happened to the tail of that series? Okay, when a series is convergent, its tail of the series must be a small number, a finite number, or it must be some less than epsilon. Okay, in which a series, suppose we have a series some a1 plus a2 plus a3 plus etc. This series convergent ആണെന്ന് പറഞ്ഞാൽ ആ സീരീസ് നമ്മൾ ആഡ് ചെയ്ത് പോകുമ്പോൾ നമുക്കൊരു ഫൈനൈറ്റ് നമ്പർ കിട്ടണം. വി ഹാവ് ടു ഗെറ്റ് എ ഫൈനൈറ്റ് സം വെൻ യു ആഡ് ദീസ് നമ്പേഴ്സ് ഓർ ദീസ് എലമെൻറ്റ്സ്. ഓക്കെ, സോ ഒരു പെർട്ടിക്കുലർ സ്റ്റേജ് വരെ അതിനൊരു വലിയ നമ്പർ ആവാൻ ചാൻസ് ഉള്ളൂ. ആഫ്റ്റർ ദാറ്റ് nth സ്റ്റേജും ഈ സമ്മ് കൂടി വരികയാണെങ്കിൽ അതെവിടേക്ക് പോകും? ഇൻഫിനിറ്റിയിലേക്ക് പോകും. സോ ദാറ്റ് കനോട്ട് ബി സമ്മബിൾ. ഓക്കെ, സോ ഒരു പെർട്ടിക്കുലർ സ്റ്റേജിന് ശേഷം ആ സീരീസ് നമ്മൾ കൂട്ടിക്കഴിഞ്ഞാൽ, അവസാനത്തെ ഭാഗങ്ങൾ കൂട്ടിക്കഴിയുമ്പോൾ നമുക്ക് എപ്പോഴും ഒരു കുറവ് നമ്പറേ കിട്ടാൻ പാടുള്ളൂ. ദാറ്റ് സം മസ്റ്റ് ബി ഗോസ് ടു 0. ദെൻ ഓൺലി ദ ഹോൾ സം വിൽ ബി ഫൈനൈറ്റ്. ഓക്കെ, അപ്പോൾ അതിൻ്റെ ടെയിൽ ഓഫ് ദ സീരീസ്, വെൻ എ സീരീസ് ഇസ് കൺവേർജൻ ആഫ്റ്റർ nth സ്റ്റേജ് ഇറ്റ്സ് ടെയിൽ ഓഫ് ദറ്റ് സീരീസ് വിൽ ബി ഗോസ് ടു 0. ഓക്കെ, സോ വാട്ട് ഈസ് ദിസ്? nth സ്റ്റേജിന് ശേഷമുള്ള എപ്സിലോൺ ജെ സ്ക്വയർ എന്ന് പറയുന്ന സീരീസിൻ്റെ സമ്മാണിത്. സോ ദിസ് വിൽ ബി ഗോസ് ടു 0 സിൻസ് ഇറ്റ് ഈസ് ദ ടെയിൽ ഓഫ് ദ സീരീസ്. ഇറ്റ് ഈസ് ദ tail of the series sigma k equal to 1 to infinity epsilon k square, and this is a convergent, right? It is convergent. Therefore, that must be goes to 0. That must be goes to 0 means this will be less than epsilon, right? So which implies fn k minus fn. That means after the nth stage, if you consider difference between any two elements, fn plus k varnal, you consider here fk plus 1 minus k means this is the difference between two consecutive elements in that sequence. Here the difference between any two elements in that sequence after the nth stage, that is the difference between them. Okay, ഇതെന്ന് വെച്ചാൽ രണ്ട് അടുത്തടുത്ത ആൾക്കാരുടെ ഡിഫറൻസ് ആണ്. ഇത് ഈ ഒരു സ്റ്റേജിന് ശേഷമുള്ള ഏത് രണ്ട് ആൾക്കാരെ എടുത്തു കഴിഞ്ഞാലും തമ്മിലുള്ള ഡിഫറൻസ് ആണ്. ഓക്കെ, സോ ദാറ്റ് വിൽ ബി ലെസ് ദാൻ എപ്സിലോൺ മീൻസ് അവർ സീക്വൻസ് fn is Cauchy. So every rapidly Cauchy sequence will be a Cauchy sequence. Okay, so now for the next statement, furthermore every Cauchy sequence has a rapidly Cauchy subsequence. Okay, now to prove every Cauchy sequence has a rapidly Cauchy subsequence, I consider fn be a Cauchy sequence in our normed linear space capital X. Okay, now we choose a strictly increasing sequence of natural number nk. To prove f has a subsequence fnk which is rapidly Cauchy, right? We need to prove that fn has a subsequence some fnk which is rapidly Cauchy. When it is rapidly Cauchy, we need to construct a series of convergent series of positive numbers, right? അപ്പോൾ എനിക്ക് ഇനി എന്താ വേണ്ടതിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള ഒരു സബ്സീക്വൻസ് കണ്ടുപിടിക്കണം. ആ സബ്സീക്വൻസിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള ഒരു കൺവേർജൻറ്റ് സീരീസ് ഉണ്ടാക്കണം എനിക്ക്, അല്ലേ? ദാറ്റ് മസ്റ്റ് ബി എലമെൻറ്റ്സ് ഓഫ് ദ ഫോം പോസിറ്റീവ് എലമെൻറ്റ്സ്, positive real numbers. So choose a strictly increasing, strictly non-negative ആണ് ഉദ്ദേശിക്കുന്നത് കേട്ടോ, strictly increasing. Now choose a strictly increasing sequence of natural numbers nk. അതെങ്ങനെയാണ് തിരഞ്ഞെടുക്കുന്നത്? For which we are constructing the sequence such a way that fnk plus 1 minus fnk is less than or equal to 1 by 2 raised to k for every k. What is this? How can you get this relationship? Since fn is a Cauchy sequence, you can construct any subsequence fnk. You take a subsequence fnk of fn such a way that fnk plus 1 minus fnk less than or equal to 1 by 2 raised to k for every k. Okay, then you know what is this? I consider this 1 by 2 raised to k as the epsilon raised to k. Okay, so what is this epsilon k here? 1 by 2. Now when we'll say that this sequence is Cauchy, is not Cauchy, it's rapidly Cauchy. Now we prove the subsequence fnk of fn is rapidly Cauchy. So for that we want, that is we prove sigma, what will be? Sigma epsilon k square, right? Convergence sequence epsilon k such that what will be epsilon k here? 1 by 2. Okay, sigma, I write some k equal to 1 to infinity. Consider that we prove the series 1 by 2 raised to k whole raised to 1 by 2. Okay, this series is convergent. Okay, when how will you prove this series is convergent? What is the this series has the elements of the form when k equal to 1, this is 1 by 2 raised to 1 by 2 plus 1 by 2 square raised to 1 by 2 plus 1 by 2 cube raised to 1 by 2 plus etc. That means 1 by 2 raised to 1 by 2 means 1 by root 2, 1 by root 2 square, 1 by root 2 cube plus etc. This is our series. And you can see that this is actually a geometric series, right? A equal to 1 by root 2, and what is the common ratio? 1 by root 2, right? 1 by root 2, and common ratio 1 by root 2. So what is the modulus of common ratio? That is 1 by root 2 again, that is strictly less than 1, right? When a geometric series with a common ratio less than 1, that will be convergent. Okay, so here sigma k equal to 1 to infinity 1 by 2k raised to 1 by 2 is a geometric series with a common ratio r equal to 1 by root 2 which is less than 1, therefore it is convergent. Okay, so we get this is convergent, and we have norm of fnk plus 1 minus fnk is less than or equal to 1 by 2 raised to k, or this can be written 1 by 2 raised to k raised to 1 by 2 whole square. This can be written like this. This will be cancelled. Again you get 1 by 2 raised to whole raised to k. Okay, so what is this? This is an element, the whole thing is an element in this series, right? So this can be written some epsilon k. Okay, so this is equal to, this is our series sigma k equal to 1 to infinity epsilon k. Okay, then this of the form some epsilon k, so this is epsilon k square. So which implies fnk sequence is rapidly Cauchy. So every Cauchy sequence will have a subsequence which is rapidly Cauchy, and every rapidly Cauchy sequence will be Cauchy always. Okay.